Hi, my name is Nicholas Espinal. This is the 8th question from my Chapter 29 quiz, and this is what it asks. A conducting bar moves along frictionless conducting rails connected to a 4 ohm resistor as shown in the figure. The length of the bar is 1.6 meters, and a uniform magnetic field of 2.20 teslas is applied perpendicular to the paper pointing outward as shown. A. What is the applied force required to move the bar to the right with a constant speed of 6 meters per second? And B, at what rate is energy dissipated in the 4 ohm resistor? So this question has two parts. We're going to answer the first one, the applied force required to move the bar to the right with a constant speed of 6 meters per second. So if we have this bar moving to the right through a magnetic field, we're going to be creating what's called motional EMF. It's going to develop an induced EMF on the bar, and that is represented by B, the magnetic field, L, the length of the rod, and V, the velocity of that rod. So we are already given these values. The magnetic field is 2.20 teslas, the length of the rod is 1.6 meters, and the velocity is 6 meters per second. So we get 21.12 volts for the induced motional EMF. But this is asking for the applied force. And we could use Ohm's law to find the current. But why would we need the current? Because the current is found in the force equation. Force is equal to the current times the length vector crossed the magnetic field vector. So we need the current in this case, and we can use Ohm's law to find that current. We're given the resistance. If we divide the EMF by the resistance, we'll get the current. And we do that, we get 21.12 volts over 4 ohms. That's going to be equal to 5.28 amps. That's the current going through the bar. So we use the equation on the right to find the force. We have the length vector because, in fact, it's because of the current, the induced current is now going down the bar instead of going up because of the induced EMF. It causes the current to go down the bar, which is why this direction is negative J. Either way, we input these values, 5.28 amps times 1.6 meters, cross 2.20 teslas, you're going to get 18.6 newtons in the negative I direction, meaning it's going to the left. But in this question, it doesn't ask for the direction, it's just asking for the applied force, and that's going to be 18.6 newtons, and we answered part A. So part B, at what rate is energy dissipated in the 4 ohm resistor? So the rate of energy being dissipated, the rate of energy, joules per second, that is power. So the power dissipated into the 4 ohm resistor is the current squared times the resistance. So we have those values. We just found the current. So we're just going to square the current, multiply it by the resistance of the 4 ohm resistor, and we're going to get 112 watts. And there we go. We answered part A, force is 18.6 newtons, and we answered part B, which is 112 watts. Thank you.